So here's a quick video about number calculations. There's a couple of concepts in here that confuse students, so I'm going to try to make it as easy as possible. So please watch this video all the way to the end. If you have questions, let me know. So first of all, arithmetic in Java. Here are the symbols that you use: add, subtract. The multiplication symbol is the asterisk that's over the 8, or the star that's over the 8. And here's your division symbol. And Java uses PEMDAS. So if you remember that from 4th or 5th grade, please excuse my dear Aunt Sally, or parentheses, exponents, multiplication, division, addition, subtraction. It will do things in that order. Now there is a weird thing that happens when you divide two integers, and this is one of the points that I want to talk about today and try to make it clear as to what is happening. So if I divide two integers here, if I have 3 and 4, integer x and integer y, I've declared them as integers. If I print out 3 divided by 4, we all know it's 0.75, but Java is going to give us a 0 there. And let me explain to you what's happening and why Java is doing that. Well, when it divides 3 by 4, when Java divides 3 by 4, it does it correctly. It knows that 3 divided by 4 is 0.75. However, these two values are integers, so Java can only store this value of 0. And what it does is completely gets rid of anything after the decimal point. Now, if you want to think about it, the concept of rounding, it doesn't do your like middle school rounding where if it's 0.5 or up, it's going to round up, and 0.4 and below, it's going to round down. It always rounds down. Actually, it just truncates. It just takes off whatever's after the decimal point there. And it's because it cannot store anything but the integer. So the value ends up being 0. So one more, if I did 13 divided by 8, if you look at your calculator, you get 1.625. If these are both integers, well then, the only thing that Java can store in memory is the 1. And it completely truncates the 6 to 5. So if you try to do the integer division, 13 divided by 8 in Java, it's going to give you the number 1. Hopefully that is clear to you. If not, please reach out to me and I will explain it until you get it. But the next question is, okay, I see what's happening, Mr. G. How do I fix it? Well, to fix it, all you have to do is create a double variable. So if I have two integer values, when I do the division, I have to store it in a double. A double has the room for the decimal points. So double z equals x divided by y. And if I were to print out z, I would get the value 5.5. But let's look at what's happening here. If I do 11 divided by 2, Java knows how to store the information, or knows how to do the division problem. It knows that's, hey, that's 5.5. But now my z is a double, which means it has tons of room to store the decimal. Actually, it can store something like 2 to the 64th power number of digits after the decimal point. I don't know, something ridiculously large number there. But because it's a double, it's able to store any values after the decimal point. And so I've fixed my integer division problem by storing my answer in a double. And if you ever want to take the average of something, which you may have to do in one of your lessons, make sure that the variable that you create for the average is a double. And then make sure you use PEMDAS correctly when you are doing the average of two numbers there. Okay, moving on, there's something you're going to learn about called Unary Operations. And it's just a shortcut. Programmers come up with shortcuts all the time. So x++ is called a unary operation. All it means is, hey, add 1 to x. We do a lot of counting in computer science, as you'll see, and instead of writing x equals x plus 1, we just type x++. And the same with subtracting 1. You can do x minus minus. That means x equals x minus 1. Couple other shortcuts. These are called compound assignment operators. And for example, x plus equals 3. If I were to type that, well, that means x equals x plus 3. Again, this is a shortcut. If my variable name was compound assignment operator, that's a long variable name. If I wanted to add 3 to it, I'd have to just say compound assignment operator equals compound assignment operator plus 3. Or I could use the compound assignment operator and just say compound assignment operator plus equals 3. And so I've made a shortcut basically. And it works with all of the different signs here. X minus equals 3 means x equals x minus 3. X times equals 3 means x equals x times 3. And x divided equals 3. Basically, you're taking the number and you're dividing it by 3. You're taking the number and multiplying it by 3. You're taking the number and subtracting 3. You're taking the number and adding 3. So hey, play around with those in this week's assignments. See if you can get them to work. See if they are not confusing to you. There's one more operator we need to talk about, and it is called the modulus operator. And it's a percent sign there. And we do something called modular division. And all it is the remainder of a division problem. So 5 modulus 2 means find the remainder when I divide 5 by 2. It's not how many times does 2 go into 5, it's hey, what is the remainder after I do this division problem? And you may have to think back to, I don't know, 4th, 5th grade math when you did long division like this, right? Well, 2 goes into 5, it goes in twice. 2 times 2 is 4, and then I subtract. 5 minus 4 is 1. And that's the remainder. 1 is the remainder. Don't grab the 2. 2 goes into 5 twice, but the remainder is 1 there. So 5 modulus 2 is equal to 1. And again, this is find the remainder when I divide 5 by 2. That's all it's talking about. If you do not understand this, please reach out to me and I will help you. Some common uses that you'll use it for: patterns to tell even and odd numbers, time calculations, money, and encryption on the internet. We will definitely be doing a couple of these things in class, but hey, it only works on integers. You cannot do this with a double. And of course, modulus has a compound assignment operator. I'll be honest, I never use this one, but you can play around with it if you want. So if I did x modulus equals 3, well, that just means x equals x modulus 3. If I were to do that, I would do 10 modulus 3, which what is the remainder if I divide 10 by 3, and that is 1. Okay, the last thing I want to talk about is you're going to have some questions this week where you have to get the digits from an integer. It's a classic computer science problem. For example, if I have an integer 842, I want to get out each digit, 2, 4, and 8. In order to do that, you have to use a combination of modulus and integer division. Let me take you through the process. To get the first digit here, this 2, all I have to do is take x and modulus 10. So digit 1 is x modulus 10. Well, what does that mean? That means 842 modulus 10. If I'm thinking about the meaning, that means if I divide 842 by 10, what is the remainder? Well, 8 goes into 842 84 times, and the remainder is 2. Actually, when you modulus 10, you're always going to get this last digit here. So that gives me that digit 1, that's the first digit. But what about the next two? They're a little bit more difficult. First, I have to change x a little bit here. What I'm going to do is I'm going to take x and divide it by 10. I'm going to divide equals 10. Well, what does that mean? That means x equals x divided by 10. And we're using integer division. So if I do that, 842 divided by 10, Well, that's 84.2. But remember, it's integer division, so the only thing gets stored in memory is the 84. So if I divide equals 10, I actually cut off one of the digits here. So now I'm down to 84. Since I'm down to 84, I can now grab this second digit by using the same concept I did here. So digit 2 is equal to x, which is now 84, modulus 10. If I do that, I just get that 4 digit at the end. Again, when you modulus 10, you're going to get that last digit. And hey, I need to get my third digit. So all I have to do is divide it by 10 again. So if 84 divided by 10 is going to be 8.4, but remember I can only store the integer value. So that's going to give me 8. At this point I have the third digit, but it's just a good process to modulus 10. And hey, what is the remainder when I divide 8 by 10? Well, 10 goes into 8 0 times, but there's still a remainder of 8. So there's all the digits. If you don't understand this, please reach out and I will help you. But good luck on this week's assignment, and I'll see you in class.